All right, hi guys, we're on day 13, block 1. So we are going to start looking at two variable statistics. We've been only looking at one variable. So now we're going to start to compare the relationship between two different variables using different statistical methods. You will need your graphing calculator a little bit later in this lesson, so make sure it's close by, but we don't need it quite yet. So we're going to start by talking about scatter plots. You might be familiar with this term. A scatter plot is used to show the relationship between two quantitative variables, right? Two numbers. So one of the variables would be the independent variable, and that always would go along the x-axis. A lot of cases it's time, but not always. But it's basically the variable that we're in control of. And then the other variable is the dependent variable. And that will go along the y-axis. Okay, so that one, as it sounds, depends on the independent variables. So for example, like age and height. Your age is the independent variable, and then your age kind of relates to your height, right? If you're a baby versus a 13-year-old, your height's going to be different. So let's start by creating a scatter plot. This is about the distance of a flight and how much it costs, so airfare. So we're looking at lowest price airfares from Baltimore. So our distance in miles, right, that's not dependent on anything else. The distance is the distance. So that's our x. Our airfare is our height, or sorry, our y, because we think that's going to depend on how far you're traveling. So when you make your scatter plot, we'll label the x and y axis first. So let me see if I can get this to show everything at once. All right, so our distance is going to be on the bottom. And then airfare is our y axis. And then you just need to pick a scale that works for the numbers you have. So when I look at my distance, I can kind of scan through. It looks like 189 is the lowest, and 1500 is the highest. So I need to cover all of those data points. And we're going to start at 0. If you have to make a really crazy jump, you can use that squiggly line. But in this case, I think we're okay if we just count by 100. I'm going to write diagonally to fit on this scatter plot. So we should be able to cover all the values we need. So you want to make sure you pick something that's small enough so you don't have like it's easy to plot the points, but you need to be able to actually fit it on the graph as well. So I'm going to go up to 1600. All right. Our airfare looks like it goes, our lowest, about 100, 108, all the way up to 260 looks to be the highest. So here, I can start at 100. I'm going to draw my little squiggly line to show, okay, I took a really big jump, and then I'll count by tens after that. 110, 120, 130, 140. And you might not like get the scale right and have to redo it, and that's fine. If you have to kind of guess and check a little bit, kind of map it out, see what will work. All right, so there's my scales. So now you're going to plot these just like coordinate points. So our first one, 576, comma 164. And obviously we're going to have to estimate a little bit here. It's not going to be perfect. But find 576 as best you can, and then go up to 164. About there. Not perfect, do your best. So I'm going to pause the video. I want you to plot the rest. They're just coordinate points, and then compare with mine. All right, here's my finished scatter plot. So again, it's not absolutely perfect, and that's fine. The nice thing with scatter plots is we're looking for an idea of where these points are. So they should be pretty close, but they don't have to be exactly precisely on the right spot. It's just looking at the overall shape. Okay, and we'll talk about how we analyze this a little bit later on. So I think the next one is one for you to try on your own. Okay, so here's our data. So take a few minutes and plot this data in a scatter plot. We're looking at hours of sleep versus your math score. So see if you can figure out what's the x and y, and then plot the points. All right, here is my finished scatter plot. So yours should look pretty close to this. Again, doesn't have to be absolutely perfect. The big things to check, do you have your labels? And then are your scales appropriate? I counted by 50s, or sorry, not by 50s, by 5s, but I only wrote every 10's value just to space it out a little bit. If you didn't space it out like mine, so all your dots are kind of down here, that's fine. Look at the shape. Does it look about the same? Then you're good to go. Okay, so what are some things you notice about this graph? So if we had to describe it to somebody else, what might we say? So I wish we were in regular school and I could get answers from you guys, but looking at this, it looks like people who slept longer, so here's longer sleep, kind of did better, except for the one person that slept 10 hours. So maybe we'll say people who slept longer usually scored higher. I also might say things like most kids sleep from 5 to 10 hours. And I might say they scored from 65 to 100, right? I can say those things too, even if I'm not talking about the relationship necessarily, just looking at the graph. So does it seem like there could be a relationship? And explain. Well, if I were to kind of sketch a line through these points, maybe it would look something like this. We're going to talk about that in a moment here. And that looks like a nice linear relationship. As the hours of sleep increases, the test score increases, except for this guy. So I would probably say yes, more sleep had higher scores. Notice I didn't say caused higher scores. We'll talk about that in another video. But we're going to call this a positive relationship. Okay? So when we're describing a scatter plot, we want to be a little bit more specific than the things that we were just saying. So there's 3 things we mention when we describe a scatter plot: the direction, the form, and the strength of the relationship. Okay? For direction, you have 2 options. It's either positive, which would look like this, or it's negative. So you have to say one of these 2 words. Go down, right? So positive slope, negative slope. For our form, you have 2 options. It's either going to be linear. So if it's linear, the dots might look something like this, where they kind of form a nice, it looks kind of like a line, right? Or you're just going to say it's nonlinear. Now that could be many different things. Maybe it looks something like this. That doesn't look like a line, that looks like a parabola. Or, let me draw a separate one. Maybe they're just all over. This is what you'll see more often, where they're just kind of spread out everywhere. They're not following some nice line. Okay, so you have to say one of those 2 words. And then for strength, you have 3 options. We either say it's weak. So if it's weak, it might look like this, where it's like, yeah, it kind of looks like a positive linear relationship, but it's not great. You might say it's moderate. Okay, they're starting to get closer together here. Or you're going to say it's strong, a strong relationship, meaning it looks almost exactly like a line. See the differences? And we'll look at especially the strength, how to show that numerically, and the direction as well. So let's just look at some graphs, describe each graph. I'll do a couple for you, and then you're going to do the rest on your own. So for the first one, for all of them, you're going to say 3 words: direction, form, and strength. The first direction is definitely positive. The form seems to be linear. And I'd say the strength is strong. If you write moderate to strong, that's fine too, but that looks pretty strong. The next one, definitely negative. It's going down. Linear, because see, I even drew that line in just naturally. And I'd say again, moderate to strong. And the last one I'll do with you, This one, now, because it doesn't seem to be linear, I don't have to say a direction. Sorry, I didn't say at the beginning. Since it's not linear, then you don't need a direction, because how can I say it's positive or negative? So I'm only going to say two things here. That it's nonlinear. And I'd say that's a pretty moderate nonlinear. We don't really talk about strength either if it's nonlinear, so not a big deal there. Really identifying that it's nonlinear is the key here, because they're just kind of all spread out. Okay, so try the next 6 on your own here, and then I'll go through them. All right, so here are my descriptions for each. So you can go through and read them, pause it if you need to look more closely. The ones I want to point out are these nonlinear guys. I have weak here and then moderate for E. You can kind of see the weak one, they're really spread out. For E, they're a little bit closer, right? So I put moderate. But you can really nicely see all the different types of shapes we have here. Okay. So next we're going to use our calculator. So I'm going to pause my video so that I can set up my calculator screen, and I want you to get your calculator out as well. Okay, so I have my calculator here. Sorry, again, it's kind of blurry. Just do the best you can following along. We're going to look at how to do 2 variable stats in the calculator. Now this first thing is super weird and very random, but we have to do it. It's called turning the diagnostic on. You only have to do this once. So if you do it right now, you should not have to do it again for the rest of the class, unless like you get a new calculator or borrow someone else's, then you want to do this. But you have to do this to get all of the 2 variable stats features to work. So here's our steps. So let's walk through it. First, we're going to press second and then catalog. It's above the number 0. So do you see the word catalog? So click second and then 0 to get to the catalog. This little A in the corner means it's already on alpha mode. So we're going to type the letter D so we can get to diagnostic. So the letter D, okay, it's in green. It's kind of hard to see. It's right above the inverse button, but right there. So you'll get to the D's, and we want to scroll down until we find diagnostic on. Okay, there's diagnostic on. My little arrow is pointing to it. We're going to click enter. And then you're going to click enter again until it says done. Seems like we didn't do anything. It's a weird calculator thing. Don't worry too much about it. Do it once and you're good to go. Don't worry about it anymore. Okay. Now let's look at how we actually use the calculator to do some of these stats. So here we have a table, shows the temperatures in degrees and number of people who went to a carnival. So now we're going to enter our data into our list. So we're going to click stat again. We want to edit. So click enter. We're going to enter L1 and L2. I'm going to clear L1 by going all the way up, clicking clear, clear, and then click enter. So when I look at my data here, I always want to put X into L1. X is going to be our temperature because I have no control what the temperature is. And then I'm going to put the number of people, that's our Y variable, into L2. Okay. So when you finish L1, just scroll to the right and then you can type them in L2. So take a moment, enter all of those, and then play the video and we'll be back together. All right, so I've entered all of the data. I'm sorry, it's so blurry, but all my data is in L1 and L2. So now I want to look at a scatter plot in my calculator. So we're on step 3 here. It says click second and then Y equals. And then I want to turn stat plot 1 on. It should be because we've used it already. So the on is highlighted, so that's good. And I want to click the scatter plot under type. So here's types. The scatter plot is that very first one. It's hard to see on the screen, but look at your calculator. It should look like a bunch of little dots. Click enter. Make sure that your X and Y list matches what we used here, L1 and L2, which it does. You can change them by clicking second, whatever list you used. And then we're going to click zoom 9, and that'll graph it for you. So there's our scatter plot, really nice. Trace helps us see the actual coordinate points. So you can scroll around and see all those data points. So it's really easy way to see a scatter plot. Okay. So let's fill in some notes here. If a scatter plot appears to show a linear relationship, that means X increases as Y increases. then we can use our equation to find a line that follows the pattern. A huge idea here. This is called the line of best fit, also called the least squares regression line and the linear regression line. So we use these two terms, linear regression line and line of best fit. You'll see both of those. They mean the exact same thing. So let's show how to do that in the calculator. Let me scroll down here. Okay, so we entered the values, L1, L2, we made our scatter plot, great. So now we're on step 4. So we're gonna go back to stat. We wanna go over to calc, and we want lin reg. That means linear regression line, and this is the format of the equation. So it's number 4, so you can either click the number 4 button or just scroll down, click enter again. If you have a newer calculator, you might have to click enter like 3 or 4 times. Keep clicking enter until you get this screen. Okay, so we have a bunch of stuff here. So it says something like this will pop up. So let's fill in what we have on our calculator so we see where everything came from. So it says y equals ax plus b. That's our slope-intercept form. Instead of an m, it's a, but it's the same thing. In this case, a equals 6.455. Wow, that is really not in line, sorry. Oh, you get the idea. B equals negative 151.637. R squared, 0.908996. R equals 0.9534. Don't worry about R squared and R. We're going to talk about those later. We just want the first three things, Y, A, and B. So A again is 6.455. B, R squared, 0.908996, 0.9534. Not a big deal for these two. Our linear regression equation, it's going to be from A and B. It's an equation, meaning you have to write an equal sign, meaning you have to have variables. So it just looks like a regular line equation. We're going to say y equals 6.455x, see the x here? That stays as x, plus negative 151.637. You could change this to subtraction if you want, doesn't matter. So this is your slope and your y-intercept. There's one thing that's new here. When you write the linear regression equation, we put a little caret on top. It's called a hat. We literally call it y hat when you say it out loud. That means this equation represents our linear regression, our scatter plot, okay? So now it says, use the equation to predict how many people will attend the carnival. The temperature is 77. That's our x variable. So we're literally just going to plug it into our equation. So we'll say y hat equals 6.455. Instead of x, we have 77 minus 151.637. Right, so it's just a linear equation, just a line. We've seen them before, and you're plugging in a value. Type this in your calculator, and we would get 344.9. This is people, right? So we're going to say about 345 people. Make sure that you have your units for questions like this. Okay. Sorry, this video is kind of long, but I do want you to try this next one on your own. See if you can do everything. Give it a try. See what you can do. Remember, direction, form, and strength. You need 3 words. You're going to use your calculator to get the line like we just did, and then plug it in. Okay? All right, here is my final answer. So I made my scatter plot first. Sorry, I don't have it on my calculator, but I made my scatter plot. I sketched it for you here. Looks something like this on yours. So it looks to be positive, linear, and I'd say pretty strong. My sketch isn't great. Strong, if you wrote moderate, that's fine too. My linear regression equation, y hat, you do need the little hat guy. And then if I'm predicting the lung cancer rate, if it's the smoking rate is 17.3, I plug that in, and I got 74.93.